let's do this. So, hi, that guy bears a resemblance to me. So that's me. There's my bio. Everyone knows that bios are seas of text, so I like to do a graphical bio. And so this is stuff that I have done or enjoyed or am interested in. So yeah, there's generally something on there that might appeal to you somewhere. So this is, we have this Great in Guardians logo, and I have a Black Hat class in August. Logo? Okay. Okay, give me the logo.
AppArmor.net is a wiki.
But I didn't make it. I mean, I'm gonna have to contribute code if I'm gonna get to wear the logo. I mean, I'm game. Okay, so this is what we're gonna do today. We're gonna talk some theory. So, what the hell is a Kubernetes? Like, why does this thing exist? Why does everyone think it's the newest, hottest thing? You know, like, is it all hype? What do you attack? How do you attack it? How do you defend it? This is demo heavy, and if I'm feeling short on time or start to see you guys nod, I'll just skip a pile of slides and go into another demo. All of my demos are recorded because the demo gods are evil gods descended directly from Loki. Yeah, so I'll also show you a tool we've been working on that we keep soft releasing because, yeah, we're just kind of like, this is great, and we're always afraid like, well, what if there's not a good enough website behind it or whatever. So we just keep kind of like telling people in talks it exists, but really trying not to tweet the thing or anything like that. So let's get right into it. So where did Kubernetes come from? This is the this is the why it exists. And by the way, I will totally put these slides up somewhere if you ask me. I'll ask at the end where the slides are normally placed. If I don't get an answer, I'll just tell you they're on in Guardian's website. Here's what Kubernetes came from. So you've got Google, and Google's got a lot of computers, right? In 2016, that's the one time like we have a public number. Google had about 2.5 million computers, like actual physical hosts. We also know that in 2014, they were launching 2 billion containers per week. That comes out to about 3,300 containers per second. I'm going to get into like why 3,300 containers per second makes you need a whole new framework and tool. But let's talk about one of the other needs. So Google had 2.5 million servers in 2016, onto which they were, showing you your Gmail inbox or whatever. They were doing all the things that Google does. Hard drives in that year had an annualized failure rate of 1.95%. So about 2 out of every 100, 1 out of every 50 was supposed to fail every year. At 1 drive per server, and servers have more than 1 drive, but at 1 drive per server, that means they're having 133 drive failures per day, or 1 every 9 minutes. Wow, that's a lot. So
2 guys can handle it.
What's that?
2 guys can handle it.
Yeah, 2 guys can handle that. So now, if this is what you're doing, if you have 2.5 million servers spread out all over the place, doing all kinds of freaking work, you don't know, like at any given time, how much compute you're going to need to do which things and so on. You have no way of possibly saying that you're going to have one person be like, yeah, you want to stand up a VM, you could put it on that host, and you want to stand up a VM, you can put it on that host over there, right? Because these containers or these, their virtual machines, their workloads are going to live for a very short period of time, or sometimes for a very long period of time. But just figuring out like which hosts you put it on, that's a whole feature. That feature is called bin packing. Like, how do I get all the binaries that I want to run onto hosts? Yeah, how do I play that game of Tetris? At a consulting firm like ours, or like Leviathan, they generally have at least one person whose entire job it is to play that Tetris game with all the people who work there, and basically say, okay, that person will work on this for this, and so on. So what does Kubernetes do? Like, these are the kinds of things you would do. So the horizontal scaling, turns out I'm running, so horizontal scaling this way. I can add more computers to it. I can add more computers to whatever I'm going to do. Like right now, how many people are checking their Gmail? Okay, at 4 a.m. tonight, how many people are checking their Gmail? Assuming constant time zones. Yeah. So anyway, self-healing. That was that hard drive thing. You have machines. You have literally whole machines just failing all the time. How do you make it so that when machines fail, you haven't had a service go down? How do you make it so that if you started some compute job that's supposed to run once, that it's fine if the computer falls down. Being able to do rollouts and rollbacks, being able to do A/B testing, having different versions of things, service discovery, all of the stuff, orchestrating storage, managing configurations and secrets, all of that basically comes down to software-defined data center. And when we talk about containers, I don't know if I'm like trying to figure out how much to talk about container, what a container is, and I'm trying not to get too pedantic, but the short version is, the whole reason we're excited about containers is, well, in some ways, it's like you can get a lot more containers onto a physical host than you can get virtual machines, because all the containers are kind of like lightweight VMs that happen to share a kernel, but don't have their whole, otherwise, yeah. So just lightweight VMs is easy. The other, no questions. Yeah, go ahead, Crispin. What's your question?
I have an ongoing issue with someone who, in principle, should be extremely knowledgeable, and is telling me that Kubernetes does not use lightweight containers, they use real VMs. And I'm trying to figure out whether I'm confused or they're full of it.
Yes. No. So I haven't gotten into this. So Kubernetes natively is using containers. Like by default, it's basically orchestrating machines running Docker. However, there are a few projects going on. One of them is Kata containers, and that's where they're saying that's where what they've done is they've said, wait a second, you could do containers that have, gosh. So this is where I get fuzzy. The short version is there are multiple efforts that are aimed at either saying, what if we could make it so that Kubernetes could actually be managing hypervisors so that it can be managing whole on virtual machines, so we could all feel a lot safer because there's a lot more boundary. Another one is, there was a Clear Containers project that fed into the Kata Containers project, and that one came down to, what if we wanted containers to actually be a valid security boundary? Like, could we use the what's it called? Could we use the virtualization instructions in the processor and make that boundary? Like, can we make something where we have the power of a container where we're kind of starting in under a second, but also get some of the security of hardware instruction segmentation through hypervisors.
So in process of abstracting away what kind of container from Kubernetes.
Yeah, absolutely. Well, that's kind of done. Now it's a matter of saying, is that thingy good enough? Can we build enough people using that thingy that it's got support and so on? So.
And really, someone else asked a question.
Yeah. So we're going to get out of that question. So anyway, because we're in the intro slides. So Kubernetes components, here's our table of contents. I'm going to tell you what each of these things is. Boom. I'm not going to give you any time to take pictures sometimes, I'm sorry. So first, we've got a pod. A pod is the smallest unit of work in Kubernetes. It basically, whenever people are talking about containers in Kubernetes, you'll hear container come up, but in general, we talk about staging a pod, and a pod is one or more containers along with zero or more bits of storage. So the idea of a pod is all the containers that are in a pod are sharing an IP address. They might share the volumes that are there. So the biggest reason you end up putting two containers in a pod is you say, I have two programs, they both need to run on the same host. I've packaged up each of those programs as its own container image. I am going to define a pod that says, hi, I'd like this pod to have these two containers started from these two images, and now they'll share the same IP address, and they might share storage or secrets or whatever. But it's to make it so that those two programs those two containers end up on the same host. Otherwise, you have no control over where they land, or you mostly have no control over where they land. There will be small lies anytime anybody gives you a concept. So I'm trying to figure out, I'm not going to mention where the lies are, but you can ask me later, or you can read and discover. So nodes, a node is any computer, whether that's a virtual machine or physical machine, that's part of a Kubernetes cluster. Most of your nodes are worker nodes, and what that means is those worker nodes have three things. They have something called a kubelet, and that kubelet's just a program that ties this computer into the rest of Kubernetes, right? It's kind of like a local API server just for that machine. You've got a container runtime, which is almost always Docker, but doesn't have to be. It could be Rocket, it could be, it could be lots of things. It could be any of the container runtimes that are out there. And you've got something called a kube proxy, and that's basically this thing that's kind of creating IP tables rules and making it so that you can have, making it so that when any part of Kubernetes wants to talk to any other part, we're not doing any of this by IP address. Like we've got discovery and we've got rewriting that all happens. So we don't really have to talk about the kube proxy, and I won't get into it. You've got this concept of a service, and I don't think, well, we might need this for what we're doing today. And a service is, in Kubernetes, you don't say, we kind of like IP addresses are ephemeral. IP addresses can go away at any time because containers can go away at any time. Remember, the idea is to be completely fault tolerant. We have to expect that any node and every single thing running on it may fail at any time at a hardware level. It may also just, the program may crash, and we have to be able to handle that. So the idea of a service is, you say, Kubernetes, I have some containers, or I have some pods, and I want them to all receive traffic on port 80. I want to call that, I want to give a name to that set of pods. And what'll happen is you get a name in the API server. You get a name in DNS, you get an IP address, and you get a port. And if you go and reach to that IP address, the kube proxies on all the nodes will basically route your traffic to one of the pods that corresponds to that service. And this is all done with YAML, and it is a lot easier than it sounds. Or maybe it's harder than it sounds. I don't know how you're finding it so far. So last bit, and this one's really useful on the attack side for us, is a namespace. And a namespace is just a logical grouping for things in Kubernetes. The short version is you'll often have a project or a tenant that's in a namespace. I'm not gonna try to spend too much time figuring out, trust me, you'll see what I mean by that when we get into our first attack. So there's our glossary. So we have containers. We have pods that are collections of containers, smallest unit of work. We have an image that's the persistent state of a container. We have a node, the hosts that the containers or the pods are running on. We have namespaces, ways that we can group resources, and usually are used as a kind of project or tenant boundary. So let's see, what else should you know about Kubernetes? Generally in Kubernetes, you basically declare what you want the state of the world to be, and this thing then works to keep the world in that state. You say, I've got this application I'd like to run. I'd really like at least 5 copies of it running. You figure it out and make sure that, if one falls down, you start another one. I really just don't want to know, you take care of it. It's a very micromanaged setup. And you basically throw out YAML files. You can do it with JSON as well. And you pass those to the API server, and if you're allowed to ask for that, then you'll get that setup. Little bit more intro, and then we should get to play soon. So I've got my Kubernetes hoodie on, by the way. We're going to be attackers, and so that means we've all got to wear our hoodies. Everybody knows attackers always wear hoodies. Components. Kubernetes API server. There is one or more, but you have a master, and that master is running the API server, and you talk to it. Great ways to attack Kubernetes involve, curl commands mostly, or you can use the kubectl binary. So we're going to talk to the API server. We're going to say these are the configurations we want. You make it happen, and things will happen. So we're definitely going to want to attack that as an attacker. The kubelet that runs on each node is definitely a good target, because that's another kind of local to one machine API server, and we'd love to talk to that and see if it'll do things it shouldn't do for us. We have the container runtime like Docker. That's a great target. We have an etcd server, which retains the whole state of the cluster, so God forbid we get access to that. There's great info in there, and if we can change anything that's in there, that's kind of game over. That's the whole memory of what the hell's going on. So what else? There's a dashboard, the Kubernetes dashboard. It is often not running, but when you're lucky enough to find it out on the internet with Shodan, you often get to run your crypto mining software on lots and lots of high-end computers, and in a really, really fault-tolerant way. Like, you know, should your mining program crash, it'll be brought back up. Like, it's just wonderful as a criminal. And so if you find that dashboard, it's again really wonderful because it can do everything. It shouldn't just be called a dashboard. Like, it's the whole damn control panel for the car. It's like more like, you know, instrumentation and yeah. So there are metrics components and cluster services that'll give us good data, and sometimes that data is way too much. We'll attack that. Two other components we won't really attack directly usually. One's a controller manager. Oh wow, and these are broken slides. Yeah. So please note that clearly this is copy paste. So we have a controller manager that basically manages those loops that are constantly looking to see, has anything fallen down? Is everything the way it's supposed to be? And the scheduler that has to basically do that bin packing, has to say, you've asked to have 5 copies of this. This thing needs, you know, 8 gigs of RAM, and I need to go and find 5 nodes that all have at least 8 gigs of RAM free that can run this thing. So we won't usually target those directly. So, from my perspective, most of the time you're attacking Kubernetes, you start from the perspective of a compromised pod. That pod might be compromised for all different reasons. One is it might be the threat actors compromised an application that's running in a pod. You know, for example, as you'll see in our demo, you compromise a WordPress instance. You find yourself on a host, and yet that host is, wow, I'm in a container. Oh, it's not just any container. It's a container that's in a cluster. Wow, I might be able to do a lot more damage. Your threat actor might have just phished somebody. That's still, I can't believe that's like how most of our evil bad guys seem to get anywhere. Is they start out with phishing and they're like, okay, cool, I've got command execution on something. Let's see what I can turn that into. Also, the threat actor might actually be valid users trying to escalate privilege. So, what might a threat actor do? So first, they might just use the access that's provided by the pod to access other services. They might say, okay, I'm in a pod. Cool thing about Kubernetes is like rule 1. So Kubernetes basically said, we're not going to really create the network. We're not really going to create the network overlay that lets, you know, all the machines in a cluster talk to all the other machines. Like, we're going to make that an app that we're going to create a spec for that. And all these other people can compete. So you could have Weave as one possibility, and Weave, Flannel. I'm trying to like remember all the different. There are a ton of these. They all have to just basically match the CNI, which is like container networking. Let's call the I spec, and not notice that spec doesn't begin with an I. So there's a CNI spec, and part of the CNI spec is every pod should be able to reach every other pod. Every node should be able to reach every other node. Every pod should be able to reach every node, right? It's saying like no segmentation, like the whole, you don't have a CNI unless you've enabled all of this. So we'll get into kind of weaknesses in that later on. So once you're in the cluster, you have access to lots of things you might not have access to otherwise. You might attack the other container that's in your pod, right? And kind of imagine the case where you've got 2 twins and one of them eats the other in the womb, right? It's God, that's dark, sorry. I don't know, it was like I'm imagining 2 containers in the same pod and one of them attacking the other. Just like what other metaphors do you have? Baby sharks do, okay.
Tiger sharks.
Oof. Papa shark, okay. So when you're in a pod, you might start making requests to the API server, to the kubelet, asking it to say, run commands in a different pod. You can even get an interactive shell. You might start up a new pod with privilege, with a privilege that you didn't have already. You might gather the secrets that are being provided to the pods. You might talk to the dashboard. An attacker who's in a pod might interact with the etcd server, try to change the cluster state. They might, this is my favorite one, interact with the cloud service provider using the cluster owner's account. Done that a few times. It's really a blast. So I'm gonna stop doing all this theory and actually get into a demo. So this demo starts from the perspective that we've compromised a web application, a WordPress application, that was running on a Kubernetes cluster, and we want to see if we can, like, okay, we can run commands in that container, in that pod, right? Let's see if we can get out of it. So the container that's in that pod has been staged on WordPress from the marketing department. What we'd really like to do is compromise the development department. So if you look at the slides, you'll find like there's an embedded thingamabobby. What am I saying? And I'm going to just take this video and full screen it again. Good, there we go. And I'm going to just basically narrate it. And you can pretend that I'm typing, because the great thing about getting to do these videos is anytime you mistype, you can just back up, cut, and start again. So this is from the point of, I've fast forwarded to the point where, oh, you're not seeing what I'm showing. Well, that won't work. Let's just do that. And that. And lights.
They're over there.
Okay. Full service shop here. Okay, so here's what we're going to do. We're going to, our attacker, this is just Metasploit. If you've never used Metasploit, it's just, think of Metasploit as just a remote access Trojan that gives us a little bit more than a simple shell. So we've got a remote access Trojan that's running where we've compromised, where's my caffeine? Where we've compromised WordPress. WordPress is running in a pod. And so what do? I type pwd, like show me where I am. And I run a mount command, and I'm just going to grep and find out, like, hey, is there any chance that I'm in Kubernetes and there's a service account token mounted in, like that's our default? And it's like, yes, there is. That run secrets Kubernetes IO service account, that's a directory that has some useful stuff in it. And we're going to use that useful stuff. So let's list it out. We've got a CA cert, so the certificate authority that we use from inside a pod. We've got a namespace text file, and we've got a text file that has our token. So I've uploaded a kubectl binary. This thing's 50 megs, but it's nice and statically linked because it's in Go, just like the rest of Kubernetes, which means you never have to worry about dependencies. So I'm going to run kubectl. I'm going to tell it where to find my token. I'm going to tell it where to find that certificate authority, cert. I'm going to tell it what server to go against, and I'm hand waving how I found that. So we'll talk about that later on. And I'm going to say get pods. And the very first thing I do is always get pods, because that's just my simple, like, let me find out if I've got authority to do anything. Let me find out if I've got my command line options right. And when I run get pods, I get this kind of like, I get this quick little list. And it says, here's front end, and here's a Redis master. And now I'm wondering if I'm actually in the right video. Sorry. Yeah, this was that video we were doing as our bonus video. Let me take us into our, oh, that's why this one looks so much better. This is the video I wanted to show you. So here's our multi-tenant. So I've been creating capture the flag exercises for Kubernetes. I teach a class, and so I make these things, and eventually I'll open source this and give it away. But here's one of the scenarios in my Bust-a-Kube. And so the, I'm just going to skip past the like running dirbuster. Hey, so running dirbuster showed us there's actually a backdoor already planted in this WordPress because someone already compromised it. Since someone already compromised it, we can run our commands and close that and just start copying my own commands in. I want to upload some files, so I'll set up a simple HTTP server. I love this one, that little Python one-liner that gives you a web server to serve files. And now I'll do a curl, and I'll pull in my interpreter reverse shell binary, my remote access Trojan, the other side of Metasploit. And I'll set it executable, and I'll pull down kubectl, and that gets pulled. I've set this at 3 times. If I'm going too fast, you let me know. So I'll do an ls just to make sure they're there. There's those two binaries I uploaded. And now I'll run that Mrs. Bin interpreter reverse shell binary. And I'll start up a Metasploit console to catch the incoming shell. And when I do it, that gets me to that point where I've basically compromised WordPress, or rather I've used the backdoor somebody else already put there. So this is kind of the point where it gets Kubernetes specific. I ran a mount command, and when I ran that mount command, I noticed all these. I noticed all of these C groups. I noticed all of these things that have been mounted in on temp FSs, and I'm like, oh, that looks like I'm in a container, and that looks like I'm in a container in an orchestration system. And oh look, there's one that says Kubernetes. Yeah, it means I'm in a Kubernetes cluster. It's like a mount command or cat out mtab is what'll tell you you're in one. It's just kind of like one of your quick ways of knowing. Now, this being a CTF, if you look at the root file system in here, we see there's a flag at the top of the screen. So we cat out the first flag and it says, hey, you might notice this isn't your usual Linux system. You're in a cluster, my friend. It's time to bust a kube. Like bust a move. I'm really old. Anyway, container doesn't have any more flags, but can you find your way to another pod to find a flag? And one of the ways you might find your way to another pod is just to see if you can do a kube control exec, which is just like a Docker exec, except it works across computers because you're in a cluster. So I'm going to do the thing I was just talking about. There's a service account that gets mounted in, and I'm going to go and use the token from that service account. If I look at that namespace, it says I'm in the marketing namespace. So I'm going to have to make sure my commands reflect that. I need to know where the API server is, like what its IP address is. And so I'm going to go back to that WordPress backdoor and run an env command. And the reason I'm doing that is Kubernetes sets a ton of environment variables, or rather Kubernetes tells Docker to set a ton of environment variables for you to give you the info you need to be able to use the API. Why WordPress would need that, you should start to be wondering at this point. But anyway, so there's my API server, and so now I've got that IP address I needed. So I'm going to go back over here, I'll clear my screen, and I'll set up my kubectl command with that token, the certificate authority, with the namespace, and you might notice I'm just like running embedded commands inside of this line, and then server. By the way, the reason I'm doing these embedded commands instead of just like running the command once and copying it, is it's just really good practice if you're in a cloud native environment to be constantly refreshing the stuff, because that stuff might be changing on you. I mean, the API server IP address probably is going to change on you, but it's kind of like if you start watching watching online, either my demos or other people's demos, where they're doing stuff against cloud environments, they're constantly realizing like my bearer token lasts 30 minutes. I better refresh that like as part of any command that uses it. So if any of what I just said didn't make sense to you, that's okay. It was bonus. So here's a kubectl command. I set up an alias so that I can just type kubecontrol or kubectl. So I've done kubecontrol get pods. I see these two pods, WordPress and WordPress MySQL. And by the way, these are most of these things are the examples that are that the Kubernetes project puts out there as they're like, hey, if you want to figure out how to build this kind of application, take these YAML files. And so I've taken those YAML files and used those as our attack. So I run hostname, and my hostname is the pod I'm in. So I'm in the WordPress pod. And that long string, well, we don't need to talk about that right now, but I'm in that WordPress pod. And I see there are two pods. There's a WordPress and a WordPress MySQL. So let me see if I can move into the WordPress MySQL one. So I run a kubectl exec, IT, just think of that for now as interactive terminal or interactive TTY. Name of the pod, what program I'd like to run interactively. I'd like to run a shell, please. You won't always find bash, but you'll almost always find binsh. That's kind of stupid, but it just seems to be the case. We do a lot of pen tests against this, we do it against on-prem clusters, we've done it against cloud clusters, and yeah, everyone seems to leave way too many binaries in their containers. So I run that host name, and it says, you've made it into MySQL, cool. And now I see there's another flag. So let's cat out that flag. And it says, hey, cool, you found your way to another container. Actually, you found your way to a whole new virtual machine. if you are in Kubernetes and you move from one container to another, you've probably switched hosts, just kind of statistically. So your end goal is going to be to get to the developer's non-containerized host. So out of the cluster, basically. So to get there, you're going to want to see if you can hop tenants. Note, tenants in Kubernetes, generally separated by namespaces. So let's see what namespaces there might be. So I'm going to I'll run my get pods. Darn it, I couldn't get pods, but at least it told me who I was. In this second container that I've hopped into, I have a service account that is in the marketing namespace. It's the MySQL service account. The previous one I would have had if I'd like stopped to check instead of just using it was the marketing WordPress service account. So I've also hopped users now in switching pods. So now get nodes. Let's find out where my nodes are. This is a simple 3-node cluster. Let's take a look at that master node. The master nodes often won't stage work, but if you get stage work onto the master node, it's very, very nice because it usually has more capabilities, particularly in the cloud provider itself. So now I'm going to try something else. Instead of these kube control commands I'm running, I'm going to do a curl, and the SK is silent and ignore the TLS server authentication. And I'm going to talk to the IP address of one of the nodes, in this case a master node, on port 10250, which is one of the 2 ports the kubelet listens on. So I'm going to go talk to the kubelet that ties this node into the rest of the cluster. And I'm going to go and pass it an API call, /running pod /. So let's get a list of all the pods that are running on that on that machine. And I get back a big pile of JSON. Now that JSON's really a pain in the butt to read. So there's a nice little tool called JQ that'll parse it for you, and it's like JSON query. So I say, okay, give me all those pods again, but just tell me what namespace each one's in and what its name is. And so I get all of that. These are all the things that are just running on that one node. And so now I find that I've got one here called dev. In the dev namespace, I've got a pod called dev pod. Everything else was not part of marketing, not part of dev. It was just stuff that's running on the cluster. And so now I'll go and I'll take a look and say, okay, show me the stuff about dev pod. And I've got dev pod, and dev pod has two containers in it. One's called dev sync, one's called dev web. And this is kind of a regular pattern you'd see. You might see a web server process. It's going to be serving content, and then some kind of sync process that's going to be pulling that content in from wherever it's being authored. So I think, well, gosh, I really want to go after dev sync. Like I want that thing that's going to have some kind of credential to be able to pull down that pull down the changes in the content. That sounds like a nice credential I'll go after. So yeah, I think I'm going to go after that dev sync pod, the dev sync container in the dev pod. Everybody keeping up with my? Okay, cool. So now I'm going to try a different API call through the kubelet. I'm going to say run, and the name of the namespace, dev, the name of the pod, dev pod, the name of the container, dev sync. That's my thing. Run in that container, -d, so this is I'm going to pass in command equals ID. Isn't this API-driven stuff really, really nice? It's just like this is pretty intuitive, and I get things to run. So I run ID, and it's like, nope, you couldn't do that. Like, okay. Well, the exit code, like you just learn, these are by experience or by reading source, but a short version is, it's not going to work. So I'm going to turn around and go after the other container in that pod. So dev pod, dev web. I can run things in that one. I can run them as root. So, and I'll run an ls command. So I'm in a second pod running commands in a third pod through a curl command. Here's my flag. Let's cat that out. And this flag says, cool, you're out of the marketing department. Now you're in development department's namespace. So, can you get to their non-containerized machine? By the way, they're big fans of the matrix, so it's called mainframe, named for the machine's mainframe. So cool, can you get to that one? So now if this was a real CTF, you'd have to watch me trying many, many, many crappy things that didn't work. Well, they're not crappy, sorry. Many things that crappily did not work. But this isn't real, and I created the darn thing, so yeah. That's why it's called hacking and not just, Mr. Robot. So here we are. So I'm going to, from the marketing MySQL pod, run curl commands that that ask the kubelet to run new commands in the dev web, in the dev web container in the dev pod. And I'm going to run kube control get pods from there. And it says, oh, sorry, you can't do that. You can't list pods in that namespace. I'll try something else. How about get secrets? Oh, that's very nice. Turns out, like, I couldn't get to devsync to get its SSH key, but its SSH key was being published in through the Kubernetes secret mechanism. And containers in the same pod will often, but not always, both have access to the same damn secrets. So yeah, there's an SSH key, and there's a mainframe login. Well, cool. Let's do that get secret. Instead of get secrets, I'll do get secret, and I'll name the secret, and then -O for output. I can do YAML or JSON, so I'll choose YAML. And there's this bust-a-kube SSH key. What is that? God, that encryption, we're never gonna break it. I'm sorry, guys. It's a crappy demo, but this is where I got stuck. Okay, I know, some of you are. Should I be stuck here? I know, I've been lecture format. I can't engage you to get you to tell me, no, it's base64 encoded. Wonderful encryption. So base64 decoded, and there's my SSH private key. Let's go back to that, let's go back and use that same get secret, and let's grab the mainframe login. And that one says, if you want to log into the mainframe, well, what is that? It means Ubuntu at this, this IP address. Oh, okay, well, wonderful. Well, let's take that SSH key, and hopefully we're going to set good permissions in the file. It's the thing that always nails me. So write it out to a file, set good permissions on it, SSH into the machine mainframe. Yay, we have the 4th flag. You made it. But for extra credit, can you get credentials to take over the whole cloud environment? Okay, well, let's see. I'm going to go back to that place where I was getting the secret. I've got my host name. That's that WordPress place. What if instead of telling the dev web container, what if I'm going to run in the dev web container isn't a kube control, but instead it's a curl against, in a cloud environment, you often have a metadata API at 169.254.169.254. It gets different names. There are different ways but once you know which one you're working against, you can do things like this. So this one's running in AWS. So I said, AWS metadata API, could you please tell me what my account is? Like what account this thing is, what AWS service account this is running as. And it says you're running with the masters.cluster.bustacube.com. So the thing that built this, COPS, creates a masters role and a nodes role or slaves role. So now I'm going to say, okay, well, thank you, but could you give me the credentials for my current account? And if you don't chop your video really harshly and make it impossible, then what people see is, come on. That. Okay, here's your access. Here's basically what I need to start using the. I've seen penetration tests where it's like, yeah, well, your thing was running, and the application you had us test, we got command execution on it. Like they're like, okay, well that's pretty bad. Like, it's worse. Once we did, we got the credentials we needed from the cloud provider account, and let's just say we destroyed your data center. They're like, what? No, we didn't wipe it. We just cloned every machine in it and mounted it on our own machines, and well, we own every system in here, not just the app. So anyway, that's my apparently long-winded attack demo. Was that fun? Was that useful?
Yes.
Okay.
Quick but interesting.
So that's kind of, I've got a bunch more, and I'll put up the slides because this is a long talk that I've shortened for here. I've also spent more time in intro, so I'm going to keep going for a little while longer. We are not going to get through every bit in the slides, and that's fine. In the slides, you're going to find there are YouTube links for the different kinds of things we can do. So let's just talk about how that works real quick. We started that with an interpreter in marketing's WordPress container that just came out of compromising WordPress one way or another. We stipulated that we could because it was WordPress. So Next, we moved from the WordPress container into the MySQL container that backed it with just a kube control exec, because if that's not cut off, you can do it. We used that container's unfettered network access to start reaching the control plane components. That was the kubelet on the master node. Could have been the kubelet on one of the other nodes, but we got lucky and the master node was accessible. We used the kubelet's default lack of authentication to switch to hop tenants and end up, not Coke versus Pepsi. No one expects that of Kubernetes yet. That's called that you might call hard multi-tenancy. This is kind of a soft multi-tenancy. The marketing department doesn't have a lot of access. The development department has far more. So I went from marketing to development. We used the kubelet's lack of authentication to invade dev web, and then figuring out that the dev web that dev web and dev sync might be sharing the same secret. I looked at the pod secrets. I got an SSH key. I found out where to use it. I authenticated to that machine outside the cluster, and once I authenticated to that machine outside the cluster, I did something that maybe I might have been able to do from anywhere in the cluster, which was I reached out and asked for the cloud account and got it. And I guess I could add one more where we use that to do bad things, but well, the demo had to end at some point, so it ended there. So I can either talk about defenses, I can show you defenses, or I can show you an attack tool, or I can do Q&A. What do you all want me to do? Those of you who are live streaming, you don't get a vote.
I'd like to see the defenses.
Okay. Sure. Anybody else feel one way or another? Cool. First mover advantage. Okay, so first and foremost on defenses, here's I swear the thing you've got to really talk to anybody who's running a Kubernetes cluster. The patches go back 3 releases. Kubernetes releases every 3 months. That means you get under a year. That means you get under a year before your release of Kubernetes is EOL'd, is end-of-lifed, and you won't get patches. So I swear it's not just the number one lesson of, sometimes the number one lesson of security is like, oh, for God's sakes, don't have vulnerabilities present in your software we already have patches for. This is even worse, okay, you must patch, but actually you must upgrade often enough or you won't be able to patch. So just keep upgrading. And that's really important right now. And that's kind of sad because it's kind of like, it's kind of like the situation on many, many Android phones where you're like, yeah, this thing got 1 over-the-air update in its lifetime. So anyway, hopefully that changes in Kubernetes. But the other thing about upgrading is Kubernetes honestly is, we're in 1.14 or so, maybe 1.15 now. This is how many releases, well, we're in 1. anything. So this is in a lot of ways, I don't want to call it an immature project, but it's definitely actively moving and not just simply in support. So the security stuff is getting way, way better. Really fast, it's getting better often with each release. There are sometimes features that I'm going to talk to you about in defenses that didn't exist or were in beta or alpha, 6 months ago or what have you. So I've got videos and I'm trying to figure out whether I should show which ones I should show videos for. So I'm gonna maybe cherry pick a little bit. So one of the big ones, this has now become a default, but one of the big ones is I need to make sure that those kubelets won't just go and let me do anything if I can reach them on the network. So this authorization mode node will shut that thing down. And I've got the quick defense here, and I'm remembering that I think what I have to do is pull PowerPoint out of full screen mode.
Oops.
This isn't oops, this is okay.
Okay.
Yeah, it's just literally I have to pull PowerPoint out of full screen mode, which with the projector just makes the screen go black for a second while it all figures itself out. So the anonymous access thing, you saw the attack. This is how simple it is. You go to each node. This one's running on CentOS, so it's got etc sysconfig. You just find the flag in essence. What sets the anonymous auth flag in the authorization mode, and go and do anonymous auth false and set up webhook. And when we restart the kubelet, and I try that same curl command that earlier let me run commands on dev web, doesn't work anymore. So that's kind of simple defense 1. And play from current slide, back to the black screen, back to up. Come on, advance the slide. Okay, so the next defense is something called a network policy. So Kubernetes by default, like, you have to dictate every port that is allowed, every port that a pod will listen on, and so that gets you a kind of default, that gets you kind of default deny almost. But beyond that, you can have network policies that serve as incoming, that serve as an incoming firewall rule. The big one that was really important to us here was having an egress policy. And that actually took a while before all of the CNI, all the network overlay providers were supporting outbound rules. But you basically say this pod shouldn't be able to just talk to anything it can reach by IP address. It shouldn't be allowed to talk to the metadata API. It shouldn't be allowed to talk to the kubelet. Maybe it should be allowed to talk to the API server, like you decide. But we can have an egress. We can have an egress network policy. And I've got instead of doing the demo thing there, what I want to do instead is just talk about what a policy looks like. So everything in Kubernetes comes down to these kind of like YAML files, right? You're just basically you're basically talking to an API server and telling you what you want to happen. So the network policies, every YAML file has like a kind. Well, what kind of thing is this text file? It's a network policy. Cool. API version. And you name an API version. You have this metadata block which names what's the name of this policy going to be called. Call it anything you want. Call it Elmo, right? Namespace, your namespace here. Right? And then spec, and then that's whatever you want to talk about. So we'll have a pod selector and say, what pods does this apply to? And you're like, wait, what do you mean? Why do you call it a pod selector? Just list the pods. Well, it turns out like the pods will have all kinds of funky names. You saw that my WordPress pod wasn't actually called WordPress. It was called WordPress and then some random junk. And that random junk's there because there won't be one WordPress pod. There'll be like 18 scattered all over the place. And there'll be 18 at any given time. One of them's going to crash, and now we'll have another one. So now there will be 19, so we can't name them. We'll end up doing this based on labels. So this is where I'll stop and say, if you really want to get into Kubernetes, like if you want to get into attack or defense, it's really useful to go and play around with a cluster. There are, one of the easiest ways to do that is a site called Katacoda. I really should have a slide for this now, but I just thought of it right now. Katacoda. And these are like free demos, and your free demo like basically puts you on a cluster and says, this is your cluster for a little while. Like here, walk through and learn. The other one though for me that's really, really good is there are these nice thin O'Reilly books. And there's one for Kubernetes, and now I'm trying to remember what it's called, but it's like Up and Running. That's the series. So the Up and Running series from O'Reilly. There's a Kubernetes Up and Running, and the book is maybe 110, 120 pages. It's actually a pretty quick read, and it will take you through like doing things on a cluster and understanding what the heck you're looking at. And it'll tell you about labels and selectors and all that. So anyway, spec, pod selector, and then you name some ingress rules or some egress rules. So here's an example of doing that, of doing an egress set or an ingress set. So this goes and says, hey, for any pods that have the label app set to my app and role set to API, you should allow ingress only from pods that have labels app my app. So the labels don't mean anything. You create all the meaning. There are conventions, but nothing big there. So I'm gonna have a quickie demo, and I'm actually watching Brian to see if he gives me any kind of signal for time. He's not giving me any kind of signal for time, so I'm happy.
All right.
So I'm going to switch over to video.
Did you haven't talked about manifest files yet?
Nice big old YAML files?
Yeah.
Yeah. We keep talking about it. That's one.
Yeah.
Yeah.
We did a podcast this week with some gentleman from Israel, and he was talking about how manifest files, the passwords and usernames are base 64 encoding, so it makes them kind of bad if you accidentally upload them to your source repos.
We did that, yeah. Yeah, totally. Well, and we'll do it some more. Okay, so this is what happens when I want that default egress policy. I go and create that same kind of YAML file, and it says, And it basically says, hey, for anything in WordPress, MySQL, egress will be, doesn't get to talk outbound. It's a database. It shouldn't be talking outbound. Screw it. And once I do that, once I apply that network policy, and I go into that pod and try, I don't get any kind of, I can ask the kubelet to do whatever I want. I didn't reach it. My curl command doesn't terminate on it because it's not allowed out of the pod.
What level are these policies at?
What level?
They're not NACLs, they're not security.
They're actually being implemented in IP tables. So when you ask the API server to make that so, there's got to be a controller, but there's likely a controller, and that controller basically reaches out to all the kubelets, which talk to kube proxy, and kube proxy makes firewall rules, makes IP tables rules that make it so. And so if you go to if you're on one of the nodes, not in a pod, but you're on a node in a Kubernetes cluster, go and run an IP table save and watch the screen fill. And what you're going to see are a ton of rules that are mostly there to make it so that when this pod running, when this container in this, when this container on this node wants to talk to this container on this node, that all the network address translation happens to make that feel like they're on the same system. But there will also be that's where network policies end up happening. So part of the idea of all this is to make it so that part of the idea of the whole Kubernetes thing is to make it so you stop thinking about the individual, not just the individual containers, the individual pods, but even the individual nodes. Like the idea is there are a bunch of nodes. Like I took a computer, I installed a Linux distribution on it of some sort. I installed Kubernetes. I subscribed it to the cluster, and once I did that, I never think about that thing again. It is 8 of 9 or whatever you want to call it, 800 of 700 of 900, and that host might die at any time, and I don't care because the way that I'm doing the way I'm supposed to be doing everything is to assume that that host and anything running on it may completely evaporate at any given time, and I'm still going to be okay. Things are still going to be running. I'm still going to have my data. It's all, yeah. So the great thing is that if you think about all of that, and it should all just work, and we have to do this, that huge feature list, wow, this is an attacker's just wonderful lunch, because you had a whole bunch of people who were saying, we've got to make all of this work. And you're like, oh, great, cool. I love when you just had to make it work and you kept adding features because I'm pretty sure that's going to be fun for me. So let's see. Back up. Okay. What else do we have? Another, we were talking to the API server and we were at, we might ask the API server to let us do things. We could have been, when we do our kube control exec to another thing, the API server should have been telling us, no, there's no reason you have to do that. You're a WordPress instance. Why should you be able to run commands in the MySQL container over there? The way we actually make that happen, so by default, most clusters will have no such limitations. So the way you create those limitations, whether you're on-prem or in a cloud or whatever, is you use RBAC, and RBAC is a general term, but in this case, it actually means something specific. So you end up creating more YAML files. And those YAML files will be to basically, you have subjects. The subject be service accounts, as we saw there. They might be users. Most of the time, they're service accounts. And then you have things you'd like subjects to be able to do. Those are called roles. So those are grouped into roles. So I can say this role is someone who should be able to exec into pods. So I might create a role called pod execer, and I'll define what that is. And then I bind subjects to roles in a many-to-many relationship, right? So that I don't lots of code reuse. So here's what that looks like. Here's a role. This role is called InGuardian's podgetter or ing podgetter. It only exists in this namespace. I can have a cluster role that goes across all namespaces, but many roles are not. And here are my rules. This role is allowed to get in any API group the resources named pods. That's all it's allowed to do. It's allowed to get pods. It's called the pod getter. So now I have a binding and it says, hey, this binding is going to have a name. This binding is called front-end pod getter. and it's going to refer to a role. Okay, the role I want is the pod getter role. It's going to refer to some subjects. The subjects I want to refer to, it's only going to be one in this case, is front end. So this ties front end to being able to get pods. So if I do that, I have a demo video. Again, it's the, I keep forgetting I have to like exit the PowerPoint. I swear if it's not like this on Windows, I'm going to have to like switch presenting operating systems. VLC, playlist. Here's my RBAC. So I've got those YAML files. I'll apply a service account, like I'll create one called WordPress. I will create a role called getPods. I'll apply a binding that binds marketing WordPress marketing to getPods. And I'm just going to have to go and delete the deployment, delete the thing that created the WordPress pod or the WordPress MySQL pod. No, the WordPress pod. And I'm going to modify it so that it uses that service account. And once I'm done with that, I've got the WordPress can get pods. So here's my role. It's in marketing, it's called get pods. It's allowed to get pods and list pods, and same with the logs. And here's that deployment where I've had to, if I don't set a service account, it runs the default service account. What that usually means, if you see default a lot in a Kubernetes cluster, it's game on. It means nobody really thought through what should be able to do what, and so you probably have a whole bunch of God mode things that can do everything. So once I do that, when I try to run that kube control exec that you saw me run in the attack demo, it gets told, oh, sorry, that's forbidden. You're not allowed to create pods or exec in this namespace. So the way the RBAC works is if you don't say what I can do everything. Once you say I can do one action, well, now we're default deny, and so that's where it switches. So let me just switch out of that, back into slides, and I'm gonna wrap up really soon. And what I want to do is I'm choosing what to hit next. And I think that what I'd like to do is show you a tool. We have a tool that we created called Paraties. And Paraties is written in Go. It's up on GitHub. Exit out of that. And part of the reason I want to show you this demo is it shows what I can do in a cloud environment. Like when you get out of on-prem, things get even more fun. As we kind of already saw with the whole get the cloud provider. Sorry, my caffeine, I have way too little caffeine in my bloodstream. Or I have way too much blood in my caffeine stream. So this is kind of a second. I have two Paraties videos. I'm just going to show you one real quick. So you run Paraties. We've been through like 17 releases, so we're way ahead of Kubernetes that way. And this is something we wrote in Go. And the idea for this is it's kind of meant to be this thing like, I found myself in a pod, now what? And we just wanted to automate more of the attacks that you're seeing me like type out. And so we've just been making this menu. It's a very simple UI. And these are just things you can do. The biggest thing it's there to do is to say, okay, you're in one service account. Can you pivot to other service accounts so you have more capabilities? So what I'm going to do here is say I'm in the namespace marketing. There's clearly a bug. We left out a colon here. I'm in the marketing namespace. I'm in the WordPress. I'm in the WordPress service account, just the one I found in that pod. So what do I want to do? I'm going to choose 13. I'm going to request the IAM credentials from the GCP metadata API. So this is in Google instead of AWS. I'm going to go and say, hey, can you, I'm going to do that same kind of curl command you saw me do again. Well, that's 169.254, 169.254. And I'm going to say, hey, could you give me my credentials? And it'll say, sure. Here are the GCP credentials for the account that you're running as right now. I say, well, that's really nice. And as soon as it shows it to me, they get gathered. So I'm going to go and say, let me just say, why don't I go and ask Kubernetes, like this is like literally two pen tests ago, this is how I popped the cluster, because we weren't getting anywhere. They'd done a whole lot of stuff right, and then it's like, fine, let's see if we can abuse the cloud provider. And so we pulled down from the metadata API the cloud provider service account credentials, and then we used that and ran through GCS, Google Cloud Storage. It's like S3, but for Google. We went through there and we found all of the service account tokens that were used to create the cluster in the first place and hadn't been cycled because that's not a default thing. And so we built that into Kubernetes now. So if you run Kubernetes in one of these situations, it'll run through GCS, pull down all of the objects, look at all the objects that it can access. And the nice thing is that by default, any service account in your project is allowed to read any bucket, any object in any bucket in your project. It's not allowed to write, you have to define that separately, but it's allowed to read all of them. So default allow on read, default deny on write. Anytime you hear default allow, it's just like time to do your happy dance. I mean, you'll have to figure out you have to read through a whole bunch of API documentation, but then you get to do your happy dance. So we just coded this in and we said, okay, we'd like to retrieve the tokens for all the service accounts, and you should then store them. And so Kubernetes will pull them and it'll store them. And now when I say, hey, okay, show me all the service accounts I have, now it says, okay, you've got the one you started with, but then you've got all of these ones we found in GCS. And just to show you that we've used one, I mean, that these are useful, I've selected the admin one. And now it says, okay, you've switched to GCS acquired admin service account. Now what do you want to do? And it's like, okay, how about if we switch namespaces over to kube system, which is where all the control plane components of Kubernetes are running. So we do that. And then we say, okay, now that we're in that, the API server should let us do damn near anything we want in that namespace. So let's run a command in one or more pods. Let's run a command in all the pods in the namespace. And the command I want to run is ID. Just to demonstrate, okay, I can run commands in every bit of the restart playback, continue playback, restart playback? I don't know. So that's my, we're looping and looping, so I'm going to just apologize for that and end on a slide. But that's basically the, yeah, that's the fun. So Kubernetes is fun. You should grab it. You should use it. Next time you find yourself in a pod, in a cluster, even if you didn't break in, even if you're just on your own cluster to see what it can do. And then you should learn Go and start working on it too. And make some pull requests because we're happy for the help. Because we're a bunch of consultants, and consultants are defined as people who have no time because that's the thing they sell. So anyway, that's it. And I work at InGuardians, and we have a weekly briefing thing, and it's fun. You pull it, and you'll get some story that we found in the news, and then like some technical advice on what to do, and that technical advice will be readable by a CIO or a whatever, and useful to the geeks who have to fix the things. So anyway, I think that's me. No, thank you. Yeah.
So I have some notes. I was taking notes for the talk and actually for the
I was going to say, didn't you have a presentation to make first?
No, I do, actually. But it was more important to you, the talent, other than myself, just lowly organizer. So I'm using the microphone for the people streaming. So hi, I'm Brian. I'm the organizer of SeaSec East.
Hi, Brian.
Hi, thanks. Thank you, Dr. Crispin. So if any of you have been listening to the podcast recently, we've kind of teased Project Hannibal. If you've been listening the last week, we announced what Project Hannibal was about. We're having a conference. There it is, right there. I don't have slides, I apologize. The actual conference is called the InfoSec Campout. As we were talking in the area over there where the food is, this is like Tour Camp, except when it sucks, you can go home if you want. So we actually created a nonprofit called the InfoSec Education Foundation for this. So we are going to be taking sponsorships for it. The cost for the tickets for the conference themselves, if you want to attend, is $20. And if you want to camp with us at the Tolt McDonald Campground in Carnation, Washington, it's going to be $35. And the camping is Friday night and Saturday night. So you can either stay one night or both nights if you'd like. Logistically, we can have I've scheduled 9 camp spots, 4 people apiece, minus 5 people or 6 people for organizers. So about anywhere between 25 to 30 people will be able to camp if they'd like. They're really nice places. We're going to do a site visit and probably put some pictures out of what the place looks like. We will have RV spots, so there will be power, so you won't have to worry about like figuring out how to charge your phone or what have you. So the date is August 23rd through the 25th. That's a Friday, Saturday, Sunday. Technically, Sunday at noon, you have to be out of the campsite or they'll sick the dogs on you. The conference is all day on the 24th. Because of the scheduling that we've got for speakers, the speaker tracks actually start at 3 p.m. and go to 8 p.m. We have the barn. Have you been there before, the campground? Okay, so there's a barn and there was a pavilion across the river from the campsite. And I talked to this lovely lady today, and you could almost hear her pecking on the keyboard as she was writing out the reservation for me. And between Monday, when her supervisor emailed me and asked me, what is this thing you're doing with this camp out thing? And today, the pavilion across the way got taken. So thankfully, we got the barn. So we're going to have 6 talks from 3 p.m. to 8 p.m. So 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. And at 8 o'clock, anybody not camping's got to get out. But we'll have camping and then quiet hours after 10 o'clock. So we could technically still hang out around the fireplace. We just can't be rowdy and whatever. The other thing that probably will turn some InfoSec people off is there's no alcohol. See, that was awkward. That was awkward there. Yeah. Now, yes, there is no alcohol unless we're all having weddings. So unless somebody wants to have a civil ceremony or you want to re-up your wife and yours vows, we could definitely do that and have alcohol.
Will you marry me?
Oh. No, I'm taken. Sorry, my wife would be very unhappy. So yeah, we're going to do the conference on the 24th from 3 p.m. to 8 p.m. If you want to come out earlier, Miss Wendy Knox Everett, who's one of our officers of the nonprofit, which is called the InfoSec Education Foundation, and I and Matt Domko, who goes by #cyber on Twitter, and she goes by Wendy CK, I think. There are officers for the nonprofit. I'm the president for life, whatever. We're looking at workshops. We're looking at things to do before 3 o'clock. So technically the conference would start somewhere around 9 o'clock in the morning. There'd be things to do like, incident response tabletops, or, we'll have Lockpick Village, or we'll have, we have a whole, 150 feet worth of RV powered area with which to do things during the day. So we're going to try to do as much as we can, and, hopefully people will enjoy it. If you're interested, like I said, if you want to camp, it's $35 for both nights or one night if you want to be there. It will get cold at night, so we're going to have emails sent out if you want to do this accordingly. Tickets will be on Eventbrite, so we'll have that out. We're going to have a call for papers, even though I think we have at least one person who I've suggested as a DR talk. So there may be 4 or 5 slots available for talks. So we're going to do a call for papers upcoming. There's all the information, which is hardly any at all, on infosecampout.com. As a matter of fact, none of this information is on there except for the dates. I've got to add that stuff. I got to do a get push later tonight. Yeah, so that's it. We'll have more information on the site as it comes up. We'll probably get a Twitter or something started up soon too. Anybody like camping?
Cool.
Nobody's raising their hands, so nobody likes camping. Oh, okay. We do have RV spots, so if you want to pull in an RV or whatever, it has 30 amp plugins, so I can charge my Tesla there, so it's all good. It's all the important things have been covered.
That'll be
Yeah. So that'll be where it is. And if you listen to the podcast, we'll have more developments coming up as it happens. So call for papers, call for workshop. We need another couple volunteers. If you want to camp out, you'll get a free ticket to the conference as well. So, and all speakers are invited. So if anybody wants to do a talk on incident response or forensics, and of course we need sponsors. At all levels. So we do have different levels. We're trying to figure out what, the maximum level.
Do we get to put up an In Guardians is hiring recruiting poster if
Sure.
we sponsor?
Why not?
That sounds like a very good idea.
I've already reached out to Leviathan, Microsoft, NCC Group. I know a couple people there. You as well. You were the second person I contacted after Marcella at the office.
Awesome.
So yeah, if you're interested, we can definitely talk. So, all right. Thank you for watching. I hope people are watching. I did post this to our Slack. If you're interested in joining the SeaSec East Slack, you can email bds.podcast@gmail.com. That's the BreakSec podcast, if you're interested in also watching and listening to that. Or on BreakSec. And we're also on Twitter at SeaSec East, SeaSecEast. So there you go. All right. Thank you, everybody. Have a good night.
Yay.
All right, and we're done. Man, I hope the microphone was on. The guy, I saw the camera moving, so Panic's upstairs probably going, turn on the microphone! Yeah.
I think my mic was on. So
Oh,
I
God, I
might
hope
have gotten
so.
it for that.
Right on, man. Yeah, so, was everybody okay with the bring your own food thing?
Bring your
It was
own-
kind of an out of left field kind of thing, because I felt bad having Hats and Spoonie like manning the grill when we would bring food for like potluck, and people said pizza had been done to death. So I was like, ugh. But I know we only do pizza once a month, so I mean we may make it different, but yeah, there's a lot of logistical things about putting on a conference. It's like, do you have allergies? If you're allergic to trees or tree pollen, you're going to be in wood smoke. It gets very insecty at night where there's bugs biting you and stuff. Jackets, it gets cold. It gets down to the mid 40s over there.
So I do get bitten and I don't get beer. Why is this fun?
I completely agree.
Wait,
Now,
where is this? Where is it again?
Incarnation, right across the bridge after you pass Remlington Farms.
Gotcha.
There's the ball diamond.
Oh, nice.
And then right after that's like the Toll McDonald campground. There's actually a walking path that will take you from
Yeah.
the ball diamond back to that area. And there's like 20, 30 spots. They got a barn to do weddings, large events. We also thought about doing some drone stuff because there's a big open area there. People fly drones all over the place. I have a Phantom 4 I've never flown before.
I have a Phantom 4 and a Mavic Air.
Okay. So yeah, we can do some drone stuff, fly kites or,
I think that's an answer to the bugs is that we could have like flamethrowers. Like it could be how far overkill could you go in destroying the bugs?
Yeah.
I was at Costco the other day and they had these USB rechargeable battery lamps with bug zappers in it.
zappers, yeah.
Uh-huh.
$25 a set.
Wow.
See, now that's the answer
That's
to the
awesome.
bugs.
We got
What's the
citronella
answer to the
candle.
beer?
I don't.
Yeah. I was low. I didn't realize it was low tech.
But I mean, we're not roughing it. I mean, the campground is about a mile from a Starbucks and a supermarket.
Yeah.
And there's a Mexican restaurant which ain't bad in
Well,
downtown
I'm assuming there's
Carnation.
probably running water bathrooms too.
Yeah, there's a big,
Yeah,
where
it's
we're
car
at,
camping.
it's like, the RV spots are here, and then there's a big open field where people can play Frisbee or whatever, and then there's like a cement building where there's showers and bathrooms. So it's not like you gotta dig your own hole and stuff. It's definitely not tour camp, but yeah, we do need a couple of volunteers, and we're trying to figure out what all the different tiers for sponsorships will be, but, yeah.
That sounds like fun.
Yeah, and if you don't want to camp, like I said, you can come for Saturday and then go home. Yeah, we'll kick you out by 8 o'clock.
And you won't be missing beer hour.
Yeah, now, okay, that's not on anymore, hopefully, but my wife and I have maybe